Hi, everyone. Jules Urbach here from OTOY. I believe this is our fourth GTC presentation in a row. We've had some major announcements in the years past, and we're always excited to present it at NVIDIA's GPU conference. It's the heart of what we do as a company. NVIDIA's actually given us two presentations this round, and the first one's going to be very much focused on Octane and also just some of the big problems that we are trying to solve as a company around GPU rendering and where we see the future heading. So I figured I'd start by just outlining some of the things that we aspirationally want to solve in the next 5 years, right? At GTC 2020, what are the things that are going to be the big problems that have hopefully been solved for rendering? And so, clearly at the top of that list is photorealism, right? We want to have path-traced graphics. Everything needs to look perfect. And Octane Render, how many Octane Render users are in this group right now? Oh, good chunk. OK, so you guys know what we do. Octane Render has been designed to sort of provide high-quality final rendering. But what's interesting is that if you look at like ABRASH resolution, right, which is what the human eye can see in each eye, it's about 16K by 16K for a 90-degree field of view. Carmack insists you need 300 frames a second, and of course HDR is a necessity. So we're talking about orders of magnitude more pixels being rendered in real time to make photorealism work. The other, of course, important aspect, and we think this applies not just for games, but to live media, linear content. There's going to be a convergence of social, games, sandbox toolkits. All these things will be driven by a single photorealistic, live, adaptable rendering pipeline. And it'll also not be displayed on a screen. I mean, we already see the trends towards volumetric displays, AR, VR, light fields. All these things are really basically just providing a platform for immersive computing. And we think that's going to happen on mobile devices long before it's, if ever, on a PC. The other thing that OTOY in particular is betting on is cloud rendering will be a big part of the future of content and even applications. I mean, I think the world's going to be much more web-like than the app legacy binary model. I mean, I think the cloud itself will be driving the scene graph and the render graph, not a piece of code on the local machine. And that's certainly true for metaverses and persistent worlds. And then finally, the last bet that we are pretty comfortable making is that we think GPUs will be at the heart of all of these major innovations. And that's why we come to this conference every year, and we do a deep dive in where we think GPU rendering is going. What we've seen is that the raise per watt, which is the ultimate metric for both client and server of where our particular work sort of is dependent on, is very much in favor of GPUs. Obviously, the announcements this morning, we're just seeing massive increases, and that will probably happen again next year and in years to come. We are always keeping an eye out for ASICs that might simplify that somewhat, but GPUs, of course, provide a massive amount of flexibility on hundreds of millions of devices. I figured I'd also take a little bit of time to go over what we have done since we announced some of the product launches last year at GTC 2015. Our mission as a company is to provide a holistic rendering pipeline that gives and democratizes what we call sort of holographic rendering. That's basically, you want to have a holodeck experience, you want to build it, you want to participate in it. OTOY's there to provide the tools. This is showing our light stage technology, which is used probably in one of the hardest pieces of this pipeline, which is to capture actors, celebrities, presidents, video game personalities. We're also very proud of some of the work that we launched just after last year's GTC in partnership with Oculus. And we created a product just for a specific contest called Octane VR. We gave it away for free. And if you go to the Oculus 360 Photos app, all the 3D images are rendered by Octane users with this tool. And they just created some of the most stunning and beautiful content that we've ever seen using a stereo QMAP format that we developed with John Carmack and that we've been building off of in the year since this came out. It's also something that can be distributed on the web, and we're going to actually have a deeper dive in our entire VR pipeline tomorrow. We also, at last year's GTC, exactly 1 year ago, announced Octane 3. And there's a whole slew of features that our users currently are able to test with the alpha releases. And we think about 70 to 80% of what was defined on that roadmap is actually in users' hands. It's probably just worth showing what our users are rendering. Like I just grabbed this off of our Facebook group, and it's just these beautiful, amazing renders that are done by artists all over the world, and they're just phenomenal. And we're really proud of what we've been building towards with GPU production rendering with Octane 3. We've also had a lot of important help and support from our partners, our plugin developers. This ecosystem has just grown by leaps and bounds. We have over 20 plugins. This is the Houdini plugin with Octane 3 volumetric rendering. Again, the volumetric rendering was one of our big features. That was the first thing we put out in version 3. And we also have released baking support. And in particular, this opens up the door to a whole new set of plugins. The two on the right are actually using our Unreal Engine plugin. And you can see here, we actually have Octane baking a scene right within Unreal Engine, end to end, and it goes right back into the viewport. This is a really interesting workflow. Bottom left is a work in progress of our Unity plugin. I'm not sure if that's actually been announced officially, but it's being worked on and developed. And when we sort of rolled out all of the 3.0, our roadmap last year, we called it 3.x because we weren't exactly sure when some of these pieces would hit. In fact, some of these things took months longer than we thought. But we're pretty comfortable with a lot of the major pieces, including the release of Octane 3.0, which we're targeting for mid-May. So again, about probably a good chunk of the features that are in 3.0 are already in the hands of testers of the alpha version. But there's some important features that we're going to be rolling out in the beta and then the final release that for us make this a 3.0 release. So one of these is Octane film buffer support, which allows you to save the state of your render and store that in a file, and then resume it later. And in fact, all the post-processing and tone mapping can be applied after the fact. So you get a little mini Urbach scene package that you can also send to the cloud and partially start or pause or continue a render. And the entire economics of cloud rendering, which is another important piece of Octane 3's launch, is totally transformed by having this feature. And that's one of the reasons why we didn't fully commit to launching Orc until we had this in place. The other component that we're going to be exploring initially with just basically temporal upsampling is basically just like you have multi-light, which stores multiple buffers for incoming light sources. We can do the same thing with space and time. We're going to start by just upsampling your samples across multiple frames. And there's a huge efficiency when you're talking about VR renders that are now 90 to 120 or even higher. And Carmack wants 300, right? So these are things that we're trying to solve right off the get-go with the 3.0 release. And also that's part of the work that we're doing towards speeding up stereo rendering and, of course, light-filled rendering, which is a big part of our VR pipeline. The other major feature, which we've always imagined being just a day-and-date launch with Octane 3.0, is cloud rendering, just built into the actual tool itself. It's deeply integrated in Octane, not just the Octane standalone, but all the plugins. And the reason why is that just as users want the ability to sort of pull in a GPU from the network, we want to give them the ability to do the same thing with hundreds or even thousands of GPUs in the cloud. And here you're seeing, you just saw the Octane app itself. Instead of rendering to the viewport, it's actually rendering to a job that's on the website. And you have the ability to actually do version control. The actual state and the delta syncing of what's being done locally and on the cloud is totally automatic. And there are things you can even do on Orc that you really can't do in Octane standalone. You can, for example, create multiple output formats for a single render job, including some that we've created, like OKX, which is our Gear VR high-speed video format. And when you're done with a render, you can actually load up a virtual desktop, which is part of Orc. And you can see, it's basically a virtual file system. You can see all the renders that you've been creating. And you can link your Dropbox or Google Drive account and drag these files in there. There's another really interesting feature that we're kind of excited about on Orc, which is, this is actually on the flight over here. I was taking some snapshots on my my MacBook. You can actually, in a web interface, launch a virtual Octane session and load your Dropbox OCS or Orbex files and edit them and save them. And what happens from this is that you really have an entire HTML-based workflow that touches every part of Octane. You can actually create and edit your scenes in Octane standalone in HTML, and you can then connect that to Orc, render them, and basically start ingesting that data. Just to sort of give an example of how simple it is, basically you just saw me load a Dropbox file into the viewport. I'm actually still on the plane here, and I'm doing this over my cell phone. It's a hotspot, and it works. It works basically even on a plane, which is kind of the worst case scenario. So we're basically exposing work. It's the very first time we've actually offered a subscription, and we're doing monthly subscription pricing around this service. It'll start at $9.99 during what we're calling Octane test drive or test drive that'll be launched with 3.0. Basically, every month, we're basically covering things like ingestion, storage, processing for that $10 a month. We're going to give away the first month free to get users started, and that free month allows us to spend that $10 on roughly 1,000 GPU minutes. And a GPU minute is, we do have a really concrete currency of cloud compute power, and that's Octane Bench. So every person that has probably downloaded Octane has also tested their computer with Octane Bench. You know exactly what rendering power you have on your machine, and now you can map that to your cost on the cloud. And just, as a rough estimate, that $10 gets you about 8 GTX 980s running for about an hour. And that isn't a fixed cost. Those GPU minutes will actually increase over time, probably as much as 50% by the end of this year as we start to find more ways of making work cheaper. And that happens first and foremost by actually getting more users. The more users we have, the better pricing we can negotiate across multiple providers. Obviously, Amazon's an obvious one, but there's also Azure SoftLayer. We have our own data center in LA, and we're adding more every month. We're also trying to fit in CPU rendered or CPU jobs within each frame, so we can do things like OKX compression. But we also think that work over time is going to be just like buying a local GPU. Every year, it might be twice as fast for the same cost as it was the year before. And unlike buying a GPU, it's not a major investment. I mean, you basically can spend what you need over time. And we're pretty excited by that in conjunction with all the features that we've been building with Octane 3. And that list is very long. In some ways, I'd love to spend more time on that. We'll probably do more of that tomorrow. This is about our roadmap beyond that. But just to recap, Octane 3 released May 15th. A very similar upgrade path that we had from 1 to 2. There'll be a $49 upgrade for a period of time, and Octane 3 will be $399 if you're buying a new license. And then we'll have basically a $999 work test drive that will continue for a few months, and may add more possibilities as we keep building on this. So after 3.0 is released, we actually have the rest of the Octane 3 pipeline that we announced last year to complete. Some of that we've actually mapped out. And in order of importance, everything related to getting Octane itself running on every possible platform is one of the highest priorities that we're going to start with 3.1. So last year, we said that we were going to build an OpenCL port of Octane, and we did. And unfortunately, OpenCL has basically disappeared in the last year. It's not a viable path on the Mac. And so the path that we took, if some of you guys may have known, is that we basically built a CUDA compiler for every possible platform we want to support. And this is one of those platforms. If you follow our Twitter feed, you might be able to get more information about what you're seeing here. But basically, we can bring CUDA and our entire CUDA source code to any platform that we want. We don't have to change a line of code. And our lives are 1,000 times simpler. And we can put all of that time and effort and innovation back into developing new features, some of which you'll see in this presentation today. So we're also going to be developing not just multi-GPU support, but also CPU backends. And I don't think people should expect that CPU support is going to be awesome. I mean, you're probably going to have to buy a 20-core Xeon to get 50 on Octane Bench, but it's going to be there so you don't have zero support if you don't have a GPU. But we're also looking at other more exotic hardware options as they come to market. And roughly every time we add a new backend to this compiler, it's about 2 to 8 weeks of optimization, no matter what GPU it is. So our next project is doing this for Pascal. The other evolution from our roadmap last year is that rather than just doing a pure open shader language implementation in Octane, we've actually evolved that to have more of an abstract shader language compiler inside of the toolkit. And what that means is that we can then expose plugins. Front-end plugin, for example, for open shader language is one option. But we can also look at doing front ends for GLSL. And we're actually working closely with NVIDIA on exploring how to bring MDL into the system. On CPUs, we're also working on a JIT and a VM so that if we can't basically compile to the JIT, we still have a VM that can run these shaders. And I touched on one important piece, which is these native plugins that we're exposing for these front ends are modular. And that sort of exposes a larger part of the ecosystem around what we're doing with OTOY, which is we're actually going to include plugins that are packaged as Orbex files, same as materials or scenes or macros that you can bring into the scene graph, and we have a way of bootstrapping those. And they're going to be distributed similarly to materials and other Orbex assets, except they'll be whitelisted and they'll be digitally signed. But ultimately, this is a platform play that we think is going to work not just in Octane, but also on Android with the Orbex Media Player. And there's a lot of possibilities that we see being opened up by turning our C API inwards, not just having outside apps supported. So one of the things that we're looking at doing with these plugins is basically supporting other types of script nodes. We're working on experimenting with V8, so we can add JavaScript or WebAssembly. We're actually looking at a native Substance Designer plugin, which will be officially supported. Of course, physics are an obvious use case. And I think one of the interesting plugins that we want to see ship almost right away is a denoiser. And Atlas has approached us. They've got a really interesting GPU denoiser. We have it working in Octane, and we're working on getting it to be one of our first Octane 3.1 plugins. And the results are really interesting. This is 16 samples, and this is after denoising. It looks really good. Obviously, I don't think you need to render 16 samples. I think Octane can barrel through hundreds of samples, but this is definitely a really great tool, and we want to provide robust support for that with 3.1. The other thing that is high on the priority list early in the 3.1 cycle is going to be support for boned and skin character animation. I mean, right now, Alembic is not ideal, but it's not even the complete bottleneck. I mean, we want to basically have native support for character animation deeply integrated in Octane, similar to what we've shown with Brigade. And along with that, we're going to basically bring in GLTF as an alternative to FBX right within the Orbex scene file format description, because it seems to be a much faster and more robust format that we can also share with the Orbex Media Player. Other plugins, of course, cover things like new media type loaders. We're also working on a number of extensions and widgets, especially for authoring scenes and also packaging stuff for VR. And we'd also like to basically use the plugin system to expose some things that are in some apps and not in others, such as PTEX and UDIM. Those are things that could be attached over time in plugins. And we see Octane 3.1 extending this ecosystem for a very long time to come through plugins. I'm going to have to rush through the rest of this because there's so much to cover in so little time. I want to talk about the last pieces of the 3.1 roadmap, which are new displacement and rounded edges code base, adaptive sampling, and faster mesh compiling and loading. We have a new product announcement, which is actually pretty exciting in and of itself. It's called Octane Engine. It'll be offered as a subscription alongside the box license that you can get today. It's sort of in between a Octane standalone license and a server node. You can essentially boot it up, and basically it provides one really interesting feature right off the bat, which is you don't need a GPU on the local machine. So here's an example of the 3D Studio Max plugin running with no GPUs used for Octane, but the live viewport runs just as fast as if one GPU were attached to the system. So for platforms like the Mac Pro, where there's absolutely no really good way to get a high-performance GPU immediately, this is a great solution. It'll allow you to actually also mix and match your standalone or your engine licenses with different plugins. And we're also looking at doing different tier subscriptions. So you'll have a $9.99 per month subscription offering, which is great for students and maybe for a secondary license. There'll also be new plugins that will be designed around the subscription model and Octane Engine itself. Those will be $10 a month per plugin. And then we're also looking at bundles with 2 or 3 or more plugins at $19.99 each. We're also going to be targeting enterprise offerings that'll allow you to do up to 200 GPUs and also run your own private version of Orc. Other important features that are coming probably a little bit longer term down the roadmap are asynchronous rendering, collaborative scene graphs. So for example, being able to plug in Nuke and After Effects and Max and Unreal Engine all into one shared Octane engine node becomes possible. We're also looking at other, breaking up of the scene graph. For example, being able to bake a scene in Octane and feeding that back into a texture node. Impossible with Octane's current system and API, but possible with Octane Engine. And that also leads to other interesting possibilities. We do have the ability to create a light fill cache that could be used for biased rendering techniques, all done in shaders, all done with this, this engine. And the entire imaging system is also being revisited with Octane Engine and now Octane Imager, which will have its own set of plugins and tools that our very own Hesam Kalani is going to be developing our initial rollout for. And you can see here, even without going into Octane, the imager node in Octane Imager can actually do ray-traced reflections. It actually has a whole pipeline around our shader compiler that can do awesome non-photorealistic effects, including things like toon shading. I love this effect in some ways. I prefer it almost to photorealistic rendering. And then there's also an API that's going to allow you to do this in the live viewport and in motion. More importantly, as we look at doing integrations across things like Unreal Engine and rasterization pipelines, you can see here, you can mix and match the live Octane path trace viewport with rasterization, and then combine them in really interesting ways with Octane Imager. And ultimately, the entire Imager stack can actually do really good reflections, really good GI, without even going back to the actual engine itself. And the results are really nice, and they're really cheap, and they work on mobile. I've got about 4 minutes, which is an interesting amount of time for me to cover the rest of this. So I'm going to basically move into Brigade and real-time rendering, which is, as I mentioned really at the beginning, is a huge part of our goals in our future looking forward. Last year I showed a video of Brigade running on 80 GPUs. And we can actually sort of map that to Octane Bench minutes now, or scores. It's basically 3,200 Octane Bench compute units would have to be used to render the scene noise-free. So about 2 days ago on my Periscope feed, I showed the same scene running on 1 GPU. And this is actually a 980, so it's about 1/30th of the rendering power. But it actually runs really fast, and it's in real time. And that points towards a future that really means we could probably be able to do Brigade and real-time path tracing in real time without needing 30 GPUs. But really what we need to do is just get rid of the noise. And that is a very different problem that could be solved in different ways. Actually, one of the things we're working on with Brigade is increasing the frame rate to 120 or more. And similarly with Octane, we're also working towards a real-time endpoint, but we're actually looking at it from the perspective of trying to get final quality rendering. And what's interesting is that over the years, as we've announced Octanes 1, 2, and 3, we started to bring more and more Brigade into Octane, including things like OSL and the out-of-core memory work. And I think at this point, we know enough about what our future roadmap is to announce where things are heading next year, and that will be Octane 4. So that is going to be built on top of Octane Engine. So if you've paid for your Octane Engine subscription, you'll get Octane 4 when it's ready. And there's really one headline feature, which I'll cover in the 3 minutes I have left, because it's really a preview. And that is that we're going to be integrating Brigade and Octane Render together. And that's really exciting. What that means practically is that you'll have Octane Render's quality, spectral rendering, all of that final frame quality with Brigade speed and Brigade's interactivity. And that interactivity is going to be better than what you can do with an OpenGL or DirectX legacy pipeline, especially when you're going into tens of millions of polygons. That's a crazy improvement over what our options are today. So Octane 4, to sum up, integrates all of Brigade's features that we've shown to date. It'll work across all of our plugins because it's going to be built on top of the Octane Engine API. And we're also going to focus heavily on next-gen hardware, where we know we can make some significant speed gains over anything that we've been able to really test and develop on today. And we're going to be working on much deeper APIs that allow us to hook into game engines, specifically Unreal Engine, where we have the full source code and we can do a lot of amazing stuff. We see that being a big part of the Octane 4 success story. Again, the other goals with Octane 4 are to bring it to mobile devices, Vulkan, iOS, even PlayStation. These are all important targets. It's one of the reasons why we're developing this cross-compiler technology. And of course, all of the speedups that are going into Octane 4 for real-time also improve offline rendering. So this will be particularly noticeable with things where there's a lot of light sources, IES lights, point lights, things that basically currently are really hard for Octane to do in the current system will become much faster. And that's really a pretty comprehensive preview of where we're at today and where we think we're going to be a year from now. So thank you very much. I don't know if we have time for questions. There's maybe about a minute. No? OK.
No, thanks.
Thanks, everyone.